Hi everybody. I wanted to make a special update video this week on El Nino because it was declared by NOAA earlier on this week, and the media has picked up on it and just gone real strong. I've seen things like Super El Nino, Godzilla El Nino plastered in a lot of places, and I wanted to have a chat with you, a discussion that's based in scientific evidence and scientific language, as well as uncertainty, because El Nino is a very concerning issue for farmers because of its correlation with drought and bushfire. I know, the declaration of El Nino in 2023, a lot of people decided to destock, and then we got rainfalls later, and it's a very controversial thing. Because we don't always communicate the science in a way that it is understandable, and because it informs a lot of really heavy decisions. So that's what we're going to do today. We're going to have a discussion about El Nino, about what we do and what we don't know, as well as how we come to that information, so that you feel informed and equipped to make decisions as we go ahead, but also so that you have a better critical thinking lens when you're looking at the media and how they're covering the El Nino declaration. Cool, so let's get started. Just by the way, if you don't know who I am, my name is Alex Dunn. I'm a PhD student of atmospheric science at Monash University and with the ARC Centre of Excellence for 21st Century Weather. So I research and I study weather. Now, I'm not an expert in El Nino myself. I'm very lucky to be surrounded by Australia's leading experts on ENSO, on El Nino, in Australia. And so we've had a lot of discussions this week about what it means, and from those experts, how they'd even like me to communicate with the general public so that that information is really clear. So that's just a bit of a background of where I'm coming to you from. So ENSO, the El Nino Southern Oscillation, is a climate mode of variability, which means it is a natural form of change in our climate, and it oscillates between a positive state called El Nino and a negative state called La Nina. And for us in Australia, we typically think of El Nino as dry and La Nina as wet. But really what it is changes in the Pacific Ocean's temperatures. So we can see here in this schematic that El Nino has warmer than average waters in the Pacific Ocean. And for Australia, this causes dry, sinking air to occur over the continent. Whereas La Nina is cooler than average temperatures for the Pacific Ocean. And this basically has a lot of rising moist air, which brings a lot of rainfall for Australia. So that's just a quick summary of what ENSO actually is. In terms of climate change and ENSO, unfortunately, climate change and El Nino, the El Nino stage of ENSO, tend to amplify each other. They both, for Australia, increase temperatures, they decrease rainfall, they decrease snow, they can increase frost risk because we get more sunny, clear days, so really cool night times. So they're quite hand in hand. And what has occurred as global average temperatures have risen is that the El Nino state has also changed slightly. But they are two separate things. Climate change is this long-term trend of increased global temperatures, whereas El Nino, or ENSO, the El Nino Southern Oscillation, oscillates between two different phases. So that's just something to think about. So let's start now by seeing what's actually happening in the Pacific Ocean. This red patch here shows that we have warmer than average temperatures in the Pacific Ocean. And that is the first indicator of El Nino. There are 4 indicators that when the Bureau used to declare El Nino that would need to be checked. If we got 3 out of 4, we would declare El Nino. Currently, we hit 4 out of 4 of those criteria. So the Bureau doesn't declare El Nino anymore. NOAA, which is a North American institute, they declared El Nino because El Nino is a global issue. They typically have a lower tolerance for calling El Nino than the Australian checklist does, but we currently hit all 4 of those marks on the Australian checklist. So we have officially entered an El Nino phase. What we mean by that is that not only do we have these warmer than average temperatures, but across our models, and we look at multiple ensembles or multiple different runs of models, they are all showing that this section of the Pacific Ocean is continuing to warm and stay warm. So let's quickly chat about that sort of model spread. So the first thing to know about models is that there are different providers of them, actually. So we'll start with this. So this is from Jane's Weather, and you can see we have the Australian model, it's called Access, the Japanese model, the US model, the CFS version, and the PLS version. So these are all different developers of different atmospheric models. Just like they'll change some of the inputs into the data or things like that. All of the different providers of ENSO forecasts are all showing us that we are staying in the El Nino phase. Up into this only looks into December, but we are staying in it for a while. So that is different people, different computational models that are showing us, okay, we're going into ENSO. Within each of these lines individually, we have multiple ensemble members, which means we're looking here at the ECMWF forecast. This is made by the European modelers. They don't just put one bit of weather in and produce one forecast. They do this multiple times. And this creates a plume, which is what we're looking at, which is multiple different ensemble members, meaning multiple different members of the model. Okay, and what we see from this plume is strong confidence that all ensemble members are showing us increasing the Nino 3.4 sea surface temperature, which is that band in the Pacific Ocean that we're seeing. So all ensemble members are showing us that we are heading in to an intensifying El Nino. Okay, so that gives us confidence in the forecast that we deliver to you that we are going into El Nino. And then we talk about strength. And this is where we see the difference between an anomaly being, just above 2 degrees to some of them showing almost 4 degrees. Now, this is where you can see much more spread. So we have less confidence in decisively communicating that it's going to be a moderate El Nino or a very strong El Nino. That's what we don't have the confidence because there's that spread in the models. Now, what is triggering the media to pick up on this super El Nino or Godzilla El Nino, this language that we never use as scientists, by the way, is that we are hitting temperatures here in the anomaly degree that we've never seen before. And in a lot of the plots, so like the figures and the images and diagrams that we show you, there are multiple models and ensemble members of those models that the temperature bar doesn't fit anymore. We have to extend the temperature bar. So that is what is raising concern for scientists. And then that's being picked up on the media, that there are some members that are showing really, really strong temperatures for this El Nino. That is only some of the ensemble members, okay? So that's why you're hearing this very superfluous language coming. Okay. But I want to bring this down to earth about the impacts of this for your farm and your decisions. This is a somewhat complex plot But here we're looking at rainfall anomaly. So the difference in rainfall, basically when we're going into El Nino or La Nina. And what I want to communicate, top line before we look at this, a strong El Nino does not mean strong drought conditions. So just because we're getting really strong forecasts for the El Nino does not mean we are definitely going into the worst drought. Okay, there's no evidence for that. And I want to show you why that is. So when we have La Nina forecast, there is a much stronger correlation between a strong La Nina and a lot of extra rainfall. But the same is not for El Nino. The strongest El Ninos do not necessarily have the biggest rainfall anomalies. So for example, we can see, down here, we've got two very strong El Nino events. They're really low on this oscillation index. Their rainfall anomaly is nowhere near as low as, for example, this El Nino, which has a very low rainfall produced, but it's not very strong. So don't panic is what I'm trying to say. There is cause for concern. There is strong evidence, though, that El Ninos are correlated with drought and bushfire risk, and that should be taken seriously, and that should go into your farm management planning for the next months to years. But what I'm trying to say is do not destock immediately. Do not, throw the baby out with the bathwater. When you're reading media articles, stay informed, but have that skepticism that the strength does not equal high impact. Okay? That is just something to take forward with you, that I wanted to get that message out there early, because you are going to hear a lot of this. It is going to intensify how much you hear about this. And by all accounts, it looks like we are going into a very strong El Nino season. I will keep you updated as best I can. If you have questions about how we call El Nino, how it's forecasted, reach out to your Jane's Weather contact. They'll pass that on to me, and I'll make sure to answer it in the next video. Okay? Have a great week. Reach out if you need to, and we'll chat next time. Thanks.